In this video, I'll be covering question 3, part D from the 2012 AP Calculus AB free response no calculator allowed portion of the exam. I cover parts A, B, C, and D all in their own individual videos, so if you want to see those other solutions, please check out my other videos. So all those videos are going to say the same thing at the start, which is anytime you got a graph on an AP Calc problem, you want to reinforce to your test brain what that is the graph of. So we are looking at the graph of f up above here. So I would highlight that, box it, underline it, make sure you know what that is the graph of. Then diving into D, D wants to know on this interval from -4 to 3, find all the x values, the values of x for which the graph of G has points of inflection. So what does a point of inflection mean? In order to have an inflection points have to meet two criteria. It has to fit both of these things. The first thing is that your second derivative has to equal 0 there, or your second derivative is undefined. And those undefined situations are going to happen usually when you get these sharp corners, you get cusps, you get these vertical tangents going on. Those are all places where your derivative would be undefined. The second thing that has to happen, it's got to do both of these things. It needs to also change concavity at those points. And so that means that the graph needs to either change from being concave up into concave down, or concave down into concave up. And it's only those points there that are going to be the places where we would have inflection points. So it has to do both of these things, number 1 and number 2. So for us, the first step on this is going to be kind of looking for the pieces that fit this first, and then going to check if it does this second part of changing concavity. We're talking about G, so they are giving us the equation g of x. We know that g of x is equal to the integral from 1 to x of f of t dt. And we're going to need to go find the second derivative of g to do this. We've found the derivative and the second derivative in previous problems, but if this is the only video you're watching, we'll talk through all of that here. So to find our derivative, we would ddx both sides of this. On the left-hand side, the derivative of g of x would just be g prime of x. On the right-hand side, this is bells and whistles got to be going off. This is the Fundamental Theorem of Calculus Part 1. Whenever you're going from a number up to an equation on your bound here, this is always the Fundamental Theorem of Calculus Part 1. And what that tells us is that our derivative and our antiderivative, that integral symbol, they essentially cancel each other out there. They are inverses. It's like squaring a square root. And what ends up happening is whatever's up top there just drops straight in to our equation. So g prime of x is really equal to f of x, which we reinforced previously is our graph. So this is the graph of f, but it is also the graph of g prime of x. We now need to find the second derivative because that's where we go looking for our inflection points. So the second derivative of g of x is equal to the first derivative of f of x. So this is going to be equal to the slopes of the graph. Remember that f prime here, that is talking to us about the slopes. So reading the slope off of our graph is going to tell us our second derivative values. So what we want to do first is, again, we're going to go check for where the second derivative is 0 or where is it undefined. First and foremost, it would be undefined at that point there because that's a sharp corner, and that's happening at x equals -2. Then we would also have it here at x equals -1 because that's another sharp corner. Then we would have another option here. That would be a horizontal tangent line. That would be the situation where our second derivative equals 0. So that would be happening at x equals 0. Then we would have a fourth and final option here, again, where it is sharp. So at x equals 1. So all four of those points fit the first thing we need. They either have a second derivative value of 0 or a second derivative that is undefined. Now we need to go check and see if they change concavity, if they do part 2 of our requirement. So remembering that what we want to read off here is to get second derivative data, we are going to read off the slopes of our first derivative here. So we're reading off the slope of this graph, but it's really giving us second derivative data. So I come through and I put pluses and minuses on this thing. I will tell you it'll keep your brain straight when you try to reread this stuff. So I put all these pluses. So this is all going up. Those are positive, positive, positive. Then it switches direction there at negative, 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 negative. Then beyond this point, it's still decreasing. It's still going negative, negative. Then on the other side, we're going to be going positive, 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 all increasing, and then out of here it's now going to be going negative, 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 so that's all now decreasing. So we are looking for the points where it changes. And so what we can see is it changed from positive to negative at x equals negative 2. So that's going to be an inflection point. At x equals negative 1 here, there was no change. It went from negative into negative, so that is not an inflection point. At 0, it changed from negative to positive, so that is going to be an inflection point. And then again, at 1, it changed from positive to negative, and so that's going to be an inflection point. So those are our 3 inflection points. And you would just say that it's your final answer, your justification. You would say at x equals negative 2, x equals 0, and x equals 1, g of x has inflection points because, and this is where you want to tell them the sign, the two things, because the second derivative was equal to 0 or undefined, and it changes signs at each of these points. And g double prime of x, which is equal to f prime of x, changes signs at those points, those values. And that would be your final answer. And so you would have gotten 1 point on here for getting this answer correct, just having those, listing those points off, and then you would have gotten 1 additional point for having the right justification in your language down below it. And I'm going to reinforce again, put these pluses and these minuses on here. It really does. I've worked with a lot of kids on this, and when they don't put that on there, a lot of them miss this question because they just don't think about where those positives and negatives are changing. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.